The arithmetic sequence part 2. Today we're going to speak about the sum of the arithmetic sequence, which is called arithmetic series. The sum of the first n terms of an arithmetic series is this rule, which is Sn, the sum, equals n, which is the number of terms you want to add, multiplied by a1, which is the first term, plus an, which is the last term in the series you want to add, divided by 2, which is Sn is the mean of the first and the last terms of the series, multiplied by the number of terms. The mean multiplied by the number. Let me take an example for that. Find the sum of the first 50 terms of an arithmetic series. 3 plus 6 plus 9 plus 12 until I reach the 50th term. Of course, for finding this series, if I put them and plug them in the calculator, I'm going to take forever. So there has to be a rule that if I put them in this rule, I'm going to get the Sn as fast as I can. What do I need here? I need n, a1, and an, which is the last term. For this sequence, I do have the a1, which is 3. I do have the number, which is n, which is 50. But I don't have the an, which is the last term. So what am I going to do? I'm going to substitute in the rule of the arithmetic sequence, an equal a1 plus n minus 1d. By doing that, I'm going to get 3 plus 50, which is the number of terms, minus 1 and minus 1 multiplied by d. How did I get the d? 6 to 3, 9 to 6, 12 to 9. Each one of them has a 3 difference. So when I do that and add them together, I'm going to have 150. So my last term, which is the an, becomes 150. I'm going to add first term plus last term, 3 plus 150, divided by 2 to get the mean, and then multiply it by my a1. I get the final answer. Is there an easier way or faster way to do that? Yes, there is the quick way. What is the quick way? The quick way is the summation notation, the one we took previously, which is putting sigma, I equal 1, because you're starting from the first term. How many terms do I have? 50. Do I know the rule? Yes, of course, this is a very easy rule, because it is 6, 3, so it is 3 for each one of them. Put the 3n. Do I need to do anything, add or subtract? No, I don't, because it is already 3n. Putting that on the calculator, you're going to get the answer as 3825. Now, find n for the given sum. What if I do know the sum, but I don't know how many of the terms will give me that sum? If he tells me, for example, that for this sequence, or for this series, I do have this answer, 2272. I have a rule, and I'm going to say, okay, I don't know the n. I know a1, which is 9. I don't know an, because I don't have the n. Can I substitute anything in the place of the an? Yes, I can. I'm going to put my rule, a1 plus n minus 1 multiplied by d. An equal a1, which is 9, plus n minus 1, I don't have the n, that's the one I'm looking for. And then I'm going to multiply it by 4. How did I get the 4 from? 13 to 9, that's 4. 17 to 13, that's 4. 21 to 17, that's 4. So, okay, my d is 4. I multiply 4 by each one of them. I get 9 plus 4n minus 4. Put them together, like terms go together. So it is 4n plus 5. I'm going to substitute the 4n plus 5 into this equation, which is 4n plus 5. That's what I get. 9n plus 4n squared plus 5n equal 4544. How did I get this number? Multiplying it by 2 in order to get rid of my 2 down there. That's the number I have. That's the equation I have. In order to solve an equation, what do you need to do? You need to put them equal to 0. And then you put them on your calculator and find the 2 brackets, the 2 answers. The 2 answers you're going to get are either 32 or 2n equals 71. Plus, see this plus? Which means that you're going to have an answer that is a negative. Can you have a negative answer for n? Can you have a number of n, number of terms that is negative? You can't. So this answer is cancelled. So the only answer I'm going to have is n equal 32, and that is my answer.